Hello folks, I'll go over this time solving equations that involve decimals, and this is a section for fundamentals of algebra. So I'm going to go through some examples. We did equations before. It's kind of like that linear equations or basic rational equations. So the first example, let's say you want to solve z plus 0.9 equals to 1.3. So that's our first equation with the very basic one. So you want to isolate z. So that's why for this equation, as you see, we need to subtract 0.9 from both sides. And we line up the decimal points. These two will cancel. So if we subtract them, we got z equals 13 minus 9, so it's going to be 0.4. So you may write it like this if you want. That's going to be, you borrow 1, it's going to be 0, and that will become a 13. So 13 minus 9 is 4, so we got z equals 0.4. It's a solution for this problem. Another one, we have this time 0.17 times x equals negative 0.34. Now you see this time x multiplied by 0.17, so you divide this time both sides. So in order to isolate x, you divide both sides by 0.17. So these two will cancel, and we don't use any calculators. So these are the divisions of two decimals. So it's kind of, you're dividing negative 0.34 by 0.17. You can move that decimal place 2 to the right for each because you want to make the divisor a whole number. So this division is exactly the same as negative 34 divided by 17. And 17 goes into 34, 34 goes into 17 twice. So the answer will be negative 2. So we got x equals to negative 2 for this problem. So we got another equation. This time it says 2.9 equals 1.7 plus 0.3 times y. Again, the idea is same. You try to isolate y. So I need to get rid of 1.7. So I subtract 1.7 from both sides. These two will cancel. And I got 1.2 equals 0.3 times y. Again, you will see here the division of decimals. So we want to get rid of 0.3 and it's multiplied by y. So you need to divide both sides by 0.3 so that these two will cancel. For this part, you have to make the divisor a whole number. So I move that decimal place 1 to the right. Same for this one, 1 to the right decimal point. 1 place to the right. So that means y will be 12 over 3, which is going to be 4. So that's the answer for this problem. So we have the next example now. To see, it's just getting a little bit like more complicated, but it's not really that bad. Again, you will combine the like terms in here, and don't forget, folks, I want to write this down here. Our aim is to isolate x. Just leave x by itself. So there are two x's in here, 8x and 10x on both sides. You can combine them under one side, to the left side or to the right side. It doesn't matter. I'm going to choose the left side. So let's subtract 10x from both sides. See, that's it's really simple to just remove one to the other side, because now you don't have any x's on the right side. On the left side though, I have negative 2x plus 4.2 equals 11.6. As I said, I want to isolate x, so I have a bit like added constant 4.2. I have to remove that one. So I'm going to be subtracting 4.2 from both sides, and these two will cancel. So what I got is negative 2x equals to, so it's going to be 4 and then 7, 7.4. And the final part, you need to, now it's a multiplication, so I need to divide both sides by -2. So these two will cancel. Now let's divide 7.4 by 2. So 2 goes into 6, 2 goes into 7 3 times, that's 6, and then I have 14, got 4 down. 2 goes into 14 7 times, got 14, subtract, you got 0. So you see the dividend and the quotient, they should have the same decimal places. So you have one decimal place for the dividend, so that should be same for the quotient, so that's going to be 3.7. So I got that one. So x needs to be here, negative 3.7. So you see, all aim is just to combine the like terms and get x, or the variable, isolated for these problems. Here's another simple one. Yeah, this is just something similar to what we solved before. So again, isolate y, so you subtract 2.6 from both sides, and keep in mind you need to you have a whole number and you need to subtract a decimal from that whole number. These two will cancel, so you can write that 4 as 4.0. Now let's do that subtraction. So that 4 becomes a 3, I borrow a digit, and that becomes a 10. So 0.2 times y equals to 1.4. So now I need to divide both sides by 0.2. So these two will cancel, and the divisor needs to be a whole number, so I can remove the decimal point 1 to the right and this decimal point 1 to the right. So that's going to make it 14 divided by 2. So that means y is equal to 7. That's what we have for this problem. So here's the final example. That just is like a distribution in here. The first thing, now you can't combine this x and that 5x. You have to first distribute that 3 in here. So you need to multiply 2.9 and 3. Again, we don't use a calculator. So 3 times 9, 27 is 7. I carried it 2. 3 times 2 is 6, plus 2 is 8. 8, so it's going to be 8.7. We have only one decimal here in here. So we can rewrite this as 6.3 minus 5x equals to 3x plus 8.7. See, now it looks like similar to what we did before. You have two variables on one side and you have two constants on each side. So you can combine those variables. I have 3x, let's remove that one to the left side. So I have negative 3x and negative 3x, so that these two will cancel. So I got 6.3 minus 8x equals to 8.7. And then I need to get rid of that 6.3. So subtract 6.3 from both sides. These two will cancel. So I got negative 8x equals to negative 2.4. Oh, not negative. It's positive 2.4. Got 2.4. So the final stage, you divide both sides by 8. Negative 8, sorry. So these two will cancel. So you divide 2.4 by 8, it goes like 3 times, but just don't forget, let me just show you that. You divide it by 8. 8 goes 24 3 times, 24, got 0. Remember, the dividend and the quotient, they have one decimal places. So that 3 really becomes like, just write it with a different color, that will become 0.3. So the answer for this one will be x equals negative 0.3. That's the answer for this problem. Okay, I hope you liked this video. I hope it was going to be helpful. Thanks for watching. Bye.